Hello students, so welcome to the IMS Gate Academy. So those who appeared the paper for Gate 2026 Shift 1, the session 1. We got some questions like which are memory based questions. So let's discuss like what are the questions asked, how was the paper like. So some information we gathered from the student. So from students' response, the paper is not that easy. It is, we can say, the moderate paper because some areas, some subjects, unpredicted way the questions came. But some subjects are questions were easy. So let's see some questions. So let me take some questions which we got from the students here, which are memory based questions. Okay. So one question I want to take it like from COA. COA, there is a question like, let's say a question, this is basically MSQ question came, MSQ. So he's given like 8-bit number, sign magnitude numbers given now. Sign magnitude representation have given now. 8-bit sign magnitude notation they used it. Simply you understand now the 8-bit number, okay, is a sign magnitude. Use what? Sign magnitude number. So the x value is given, y value is given now. X equal to y equal to. So option A, they performed, so z equal to x minus y. Option B, z equal to minus x minus y. Option C, z equal to minus x plus y. Option D, z equal to x plus y. Like these options are given now. So they are asking which of the following operation gives the overflow under this one. So what this number is given here? So the number x is like minus 52. This is 72. But I am writing this given in a binary format I given now. These values are in binary now. 8-bit number when you write it this one now. Suppose 8-bit number, if I take positive number 8, so sign position is what is 0. So 72 means 64 I should take it. 64, 32, 0, 16, 0, 8 if I take 8, 4, 0, 2, 0, 1, 0 like this. So this number is like this I am writing 1, this is 64, 32, 0, 16, 0, 8. So this value is what? 64 plus 64 plus, so the 8 position is what? 0 only. The 4, so this position is there like 1. Okay. So then 8, 4, 0, 2, 0, 1, 0. This number is given like this. So minus 52. So minus 52. So minus 52, the sign bit should be 1 here, right? So remaining I have to take it. So 52 I should write it. 52 means what? I should take 64 bit, 32 I have to take it, 16 I have to take it. So this 32 plus 16, 48, right? 48. So I have to take it 4. So this is 32, 16, 8, okay, 4, 2, 1. This number is given like this. Actually, the given number is this one now, the given. But when you write it in binary, when you take decimal, this minus 52, this is what 72. You would understand 8-bit sign magnitude notation range. What is the range of 8-bit sign magnitude? That is nothing but 2 power n minus 1 minus 1 2 plus 2 power n minus 1 minus 1. It is same as for 1's complement also. But in case of 2's complement, this minus 1 won't be there now. That is nothing but if I take 8-bit number, 2 power of 7 minus. So minus 127 to what? Plus 127 is a range. If you know this range, we can able to answer it now. X minus y. So now what is x value? Minus 52 minus 72, right? So minus 72. This value is how much now? This will goes to be more than, so I think this number is 76 or something is given now. Let's take it. So 124. This will not give overflow, right? But I think this number is 76. This number is 76. So now we can change this value. So now what happens now? So minus 52 minus 76. So this number goes to be 128. So therefore this will use a overflow. This will produce a overflow if I am not wrong. Check it all of you. So those who attempted this paper and just confirm me. You can comment. So check it, these values are correct or not. So what I want to say simple. So if you know if the given number, whatever number is given, this incorrect. This number you would get it a decimal. Then look at the operations you have to perform it. So now what is this one? This will become positive. So this will not produce a overflow. So this becomes positive plus plus. So this will also produce what? Overflow, because 128 will come. So this minus and plus will not produce the overflow. So now option A and C will be the right answer, because MSQ question it is. Now options may be changed. So you might have to check the values. So means X value is something, Y value is something, operations are given now. I have to always see this. If you know this ranges, answering this question becomes very easy. Yes. So another question from, so let me take some more questions we got. So there is a question from operating system OS. Fork based question is there. Fork system call based question is there. The question is given. So this question is given something for I is equal to 0, I less than 3, I plus plus. Okay. So within that, if so this fork, so fork equal to 0, so then you continue. So else, so this is like this, open close, else break. So this is for loop is closed. After that, so printf hello. This is a code. You're asking that how many times printf statement, so statement is executed. How many times printf statement is executed? So this question is a numerical answer type question, OS based. I think 1 or 2 more question you need to check it. So those who answer this question. Now how to answer this question now? So this is, so let's take this a parent process, right? It's a parent process now. You understand now. We can use a binary tree to evaluate this one. Parent process. When this parent process executed, what happened? I equal to 0, I less than 3, condition is true. Now we have to execute if fork equal to 0. Now fork statement going to be executed now. The fork statement nothing but execution of fork nothing but create a process, right? So that means it will create a process C1. I'm naming the children one. So C1. So remaining parent will be here now. Parent will be here now. What we know, for a parent return value will be positive number something. For child value return value is what, 0, correct or not? That means, you know, for a parent process, this will get a positive number which is not equal to 0. That means condition is false. Condition is not false, not break. So the loop is what, break. So loop will not repeat for the parent. For this parent, loop will not repeat. So come to the child. In the child code, what happens now? So child code return value is 0. The condition is to continue. Continue nothing but this loop get repeated now. So what happened now? So I value first initially is 0. So when repetition nothing but what happens now? I has to increment. Now when I equal to 1, I am taking now. I equal to 1. This when I equal to 0 now. So now if statement will execute. The if statement nothing but again the for I less than 1 is less than 3 true. Now we have to execute this one now. So that means one more children will create. I am keeping C1 as it is. The C2 get created here now. C2 get created now. C1. So for the parent, for this person, parent is a positive. So return value is what, positive. Return value what, 0. That means here loop will not repeat. I'm right, loop will not repeat. Here loop will not repeat. Now I'm going to C2. So C2 what happened? So children were return value is 0. The condition is false. Continue the loop. So continue the loop, nothing but what happened? So now I get incremented, I equal to 2. So C2 will be here. C2 will be here now. It will create one more children, C3. C3 will come now. So for this parent, return value is what? Positive. So loop will not repeat. So C equal this. So it will happen now. This loop has to execute now. I has incremented 3. So I'll check the condition now. I less than 3. Condition is false. Condition is false means it will not run. So directly jump to what? Printf, right? So that means, so how many times printf statement is printed is that? So parent, loop will be stopped, printf will executed. So hello will come now. Loop is stopped, printf statement will execute hello. So loop is stopped, last statement will execute. Here is what? The loop for loop condition is false only, right? It will come out of the loop. So then it will run what? Last statement hello. Therefore, answer for this question is what? 4. 4 is the answer. I hope this is clear now. So let's see some more questions. So another question from digital. Another question from digital. This also MSQ question. MSQ question. This function of P comma Q equal to a Boolean expression is given now. P dash plus Q into XOR operation. XOR operation P dash Q. P dash Q. This is given now. Options are P dash XOR operation Q dash. Option B is P XOR operation Q whole dash. C is what? P XOR operation Q. Option D is P bar XOR operation Q is given now. Look at this one now. So you should know the XOR operation. So if you know the A XOR B, how to write it? A dash B plus A B dash, or A prime, you can say it. Correct. So I can use this logic. So now P bar plus Q, okay, A bar means I'll take whole bar into this one, P bar Q plus P bar plus Q into P bar Q whole bar, I'll take it. Just simplify this one. What happens? P Q bar will come, this part, plus, sorry, so into so this P bar Q will be there plus. So what happens to this one? P bar plus Q. So this will be P plus Q bar will come, right? So this simplification, this will be 0 plus. If I simplify this one, so what happens now? This will P bar Q bar plus PQ will come. This is nothing but P XNOR operation Q, or also this complementation, no? P XOR operation Q whole bar also equal. That means straightforward, one of the option is right. Similarly, we can check it this way. Any option will produce to same. Similarly, we can check it. Any other option will produce to same on. So basically, you understand now. If option A, if you try it, so what is saying that P bar, so you can do the complementation. I mean, when you do the complementation, will it produce the same thing or not? You can try it, right? P bar XOR operation, Q bar is there. If you do it this one, so what we got? P XOR operation Q, or this format I can write it now. So now this one, so when I supply to this one, what happens to here? P bar XOR operation Q bar. If I do the complementation, this one, or else, you know, you just simplify this one. P bar XOR operation Q bar, simplify it. So P bar, okay, and Q bar means Q only will come plus. P, if you write it as this, no, I mean P Q bar will come, isn't it? So that means it is giving what? P XOR operation, but we are expecting what? XNOR operation has to come. Therefore, option A is incorrect. So anyway, definitely option C is incorrect. If you try for this one, it will give the answer now. So now you can see P bar XOR operation Q. So one way is what? When I simplify it, so I can use the P as this Q bar plus, now P bar means P, then Q. So this is nothing but what? P XNOR operation Q, right? So therefore, option D also right. This is one more question. This question was framed for one more question. Let's see some more questions. So from computer network, so the 2 mark question asked, numerical answer type question is given now. It is basically sliding window protocol based question. Basically sliding window protocol based question. The question says, he has given frame size L value 1000 bits. 1000 bits given now. So bandwidth is given 100 kilobits per second, where 1k is clearly mentioned, 10 power of 3 bits here. Okay, 10 power of 3 bits is mentioned. One-way propagation delay. One-way propagation delay. So if I take P suffix D is given 100 milliseconds. 100 millisecond is given now. 100 millisecond is given now. So this is information is given now. So now processing delay. Processing like if I take the processing delay neglected, it is 0. Now queuing delay also. The queuing delay also is given 0 only, neglected. Now other all delays are what neglected here now. Now for efficiency, so sliding window protocol, efficiency is to be 100%. So what is the window size asking now? What is the sliding window size? Window size is the question now. Window size is asking now. So now sliding window protocol mentioned, he did not mention simply like SR protocol, GBN now. Sliding window protocol, window size nothing but sender window size only, right? Sender window size only. Suppose I'm taking W, so sender window size only asking now. But one condition is given, efficiency should be what? 100%. Efficiency should be 100% now. So efficiency to make the 100%, full window means full entire time we have to send it. What is the total time generally? So total time calculations, the first transmission delay will be there. Transmission delay, propagation delay will be there, right? Some processing queuing delay will be there. Processing delay will be there. Yes or no? Now receiver received, right? Now transmission delay of ACK will be there. Plus propagation delay of what ACK like propagation delay test. This is the total time now. So we have to send the full window. That's what efficiency will get 100%. Very simple, if you are studied in the class, efficiency of sliding window protocol, when you want to make it 100%, so 100% now, the sender window size, now sender window, I'm taking no, window size sender will be 1 plus 2a, I can say it. This is what shortest form you can say. Or else, simply this entire time, this total value you have to send it now. So other way also we can make it, no. So general efficiency, how to take a efficient sliding window protocol? So when window size given now, okay, window size into transmission delay by total time, correct or not? Total time. So other way of applying now, total time now. So this you have 100% nothing but 1 only, right? This 100% was what? Nothing but 1 only now. So what happens is 1 equal to this value, right? Now total time by transmission delay into W value will get what? Total time by transmission delay. Or else simply you can see, we can get the 1 plus 2a. What is 1 plus 2a, sir? 1 plus. So 2 into propagation delay by what? Transmission delay now. Just calculate the propagation delay by transmission delay, get it now. So propagation delay already given, 100 milliseconds is given now. One way propagation delay is given what? Propagation delay 100 milliseconds is given now. So we need to calculate what? Transmission delay we have to calculate. That value is nothing but L by B. So 1000 bits has given now. Divided bandwidth is what? 100 into 10 power of 3 bits per second is there now, right? So 0, 0 cancel, right? So this value is simply equal to 10 milliseconds, I can write it. This value is 10 milliseconds. So sender window size equal to 1 plus 2 into propagation delay is what? 100, right? 100 milliseconds. 100 by what? 10. So 0, 0 cancel. This value is 21. Check it all of you. Sender window size 21 is a option is there. So I think options was given. Option A 10, option B 11, option C 20, option D is 21. This option is. I hope this question is clear, everyone. So just comment out. You can check it. There is a question from compiler design. So basically from LL1 parser. So MSQ question was there. MSQ question now. Statement wise MSQ question. The statement wise given now. It is given statement wise. Statement 1. So LL1 is a left recursive grammar. You check if the statements are correct or not. So another option is given, LL1 is a left factored grammar. LL1 is a left factored grammar. The third option is LL1 is more powerful than SLR of 1 parser. SLR of 1 parser. The fourth option is given, LL1 is a backtracking grammar is given. LL1 is a backtracking grammar. So which of the following statements are true? So what is the answer this one now? What we know about LL1? So LL1 is the first one, you understand, the top-down parser, right? It is a top-down parser, right? Top-down parser, right? Top-down parser. We can also say table-driven parser also. Table-driven parser. Table-driven parser also you can say. It is a non-backtracking one. Non-backtracking grammar. Non-backtracking. So it is also non-recursive LL1 also. Non-recursive grammar also can say now. A grammar is to be say LL1, three things are essential. It should be unambiguous, right? It should be unambiguous. It should be free from left recursion. So it is left factored grammar. Left factored grammar. Or else you understand, it should be free from common prefixes. Okay. So these are the information about LL1 now. With this one we can answer LL1 left recursion grammar. It is a not left recursion, right? So this option must be false. LL1 is a left factor grammar. Yes, true. Yes, this is true now. LL1 is a more powerful than SLR1. If you see the grammar structures, you understand. So LR of 0 is there. Bottom of parsers. Every LR of 0 is what? SLR1. Like this, SLR of 1. Every SLR of 1 is what? CLR of 1. Like this. I mean, I can make it LELR. LELR of 1. LELR of 1. Like this is there. Some relation, like no, my LL1 will be like this structure, like this. LL1 will be like this. So now with this relation, I cannot say that LL1 is a more powerful than SLR1. So we cannot say this, no, LL1 is what? More. So this all things will be, under what you can say CLR1. This all under CLR1. Therefore, so LL1 more powerful, this we cannot say it now. LL1 is a backtracking grammar. So this is not a backtracking, right? Non-backtracking now. Therefore, only option A, this is A, B, C, D. So only B is correct. Only B is the right answer for this question. I hope this is clear, everyone. Another question from TOC, especially from NFA based question is given. Very straightforward, direct question, this one now. So NFA, so they given M is encoded. NFA. M is what? NFA. Has 6 states are there. How many? 6 states. So now this question is that, so which of the following is not true of number of states equivalent in DFA. Simply they are asking now number of states in DFA. When I convert into NF into DFA, options are given like this: 1, option B 32, option C 65, option D is 128, given like this. So what are you asking now? Simply NFA is converted into DFA. NFA has 6 states. When you convert to DFA, which is not possibly asking now, which of the following is not true of number of states equal to DFA? If you know this point, when NFA you want to convert into DFA, if NFA has n states, I'm saying now, NFA has what? N states. N states are there now. This n is between, you understand, when I convert less than of 2 power of m I'm taking now. Sorry, I take this 2 power of n state. It is in DFA. So number of state DFA will be this number of state DFA will be minimum 1, maximum will be 2 power of n. N is where this or else you take it, this is m I'm writing m. So now m value will be like this. Better. So 1 less than m less than 2 power of n. So now with this one, so maximum will be what? 2 power of 6, 64 only will possible, right? That means 65 is not possible. Definitely 128 also not possible. So 1 is possible, what? So this is what? B also possible. Therefore, you understand now, not to true you asking now. Not to true is nothing but C and D. D are the right answer for this question. So this also MSQ question. So in this session, there were many MSQ questions were present. So there is a question from computer networks. Computer networks, IP addressing. IP addressing system. IP addressing. The specially used classless inter-domain routing based. Okay. One of the IP, block IP address is given now. 202.16.0.0 suffix 15 is given now. Okay. Now, so ISP wants to assign 6,000 IP addresses. 6,000 IP addresses to the organization. Now question is that, so which of the following? So this CSE block IP is possible, are possible. Some sentences little change, but ultimately which of the following block IP is possible for this organization to assign it? The 6,000 IP address I have to assign, but purchased is what? This is a block purchase now. This also MSQ question. 2 mark. So option A is given now like this: 202.16.32.0 suffix 19. Option B given 202.16.64.0 suffix 19. You can check it, these options are right or not. So 202.16.0.0 suffix 19 is given. Option D 202.16.24.0 suffix 19 is given now. To answer this question, first of all, take this given block IP address. So 16.0.0 suffix 15 is given. What is the meaning here 15 now? This is what network ID part. Network ID part 15. The 15 bits are given. So what is the host ID part? So host ID part is the remaining 32 minus 15. This value is how much now? So 17 bits. 17 bits. Nothing but you understand. So this person purchased from ISP the block size. What the block size here purchased? The block size is equal to 2 power 17 IP addresses purchased. 2 power of 17 IP addresses purchased, correct or not? Out of 2 power 17 IP addresses, we want to give it what? 6,000 IP address to the organization now. So which is possible block IP for that? Or else this is supernating only, right? Correct. Which is a possible now? So always you understand, whatever sum of the IP address you are taking given to organization, always the block wise you have to take it. What is the block wise? The rules are there, like CIDR rules are there now, if you know it. So what is the block IP you taken now? So consecutive IP address you have to take it always. The block must be this block size must be power of 2. Now first IP address which you taken from the block must be divisible by the total size of the block. These are the things need to be observed. So to assign a 6000, host IP address how many, host part how many bits required, host ID part how many bits required. So you know, right, 12 bit if you take 4096, 13 bit if you take 8192. So definitely 13 bits you have to take it. So 13 bits if you are giving for this one, this implies what? Network ID part will be how much now? 13 I have to subtract, 19 bits will be there now. So now, so this is the point, right? So now block size we have taken what? 2 power 13 only we have taken. This is like, I don't know, consecutive IP address, block size must be power of 2. What are the first IP address should be divisible by block size. So now supernating time, what we understand, this ID address, first IP address we assign as the CIDR only, right? Let's check the options. So option A, 202.16.32. How to write 32? 128, so 128 position 0, 64, 32, 16, 8, 4, 2, 1 dot something will be there now. Here is what all 8 bits will be there. Correct. So this IP address, if I want to give for one of the CIDR block, this must be divisible by total size of the block. What is the total size of the block? 2 power of 13. How to understand divisible? Least 13 bit must be zeros. Then it is divisible. Here 8 bits are 0, 8, 9, 10, 11, 12, 13. Yes. So 8, 9, 10, 11, 12, 13. Least 13 bits are 0. Therefore, this is suitable option. This is possible to give organization. So B, talk for B. So 202.16.64, 64 outright, 0, 1, 128, 64, 32, 16, 8, 4, 2, 1 dot 0, 0, 0, 0, 0, 0, 0, 0, right. Again, this block, this IP address you want to give for this block ID, this must be divisible by total size of the block. Total size of the block 2 power 13. Again, 13 bits should be 0. 8, 9, 10, 11, 12, 13. Yes, 13. Least 13 bits are 0. Least 13 bits are 0. Least 13 bits are 0. Right. Therefore, this also suitable. Option C. So 202.16.0.0. You see all zeros only there. Definitely this also suitable candidate. Option D. 202.16.24 is given now. 24 outright. 128, 64, 32, 16 have to take it. 16, 8, 4, 2, 1, right. Dot 0, 0, 0, 0, 8 zeros here. Correct. So now to count it 8, 9, 10, 11, 12. The 12th bit, 13 bits are 1. Therefore, this is not possible to assign. So now with this one, what I can say, A, B, C possible, D is not possible. Answer to the question is what? So A, comma, B, comma, C. Like based on your options only, your answer will get. This is a MSQ question. See, there are many MSQ questions for there. So I hope this solution is clear, everyone. Let me take some more questions. So there was a question from operating system, deadlock based. This question also was easy. Deadlocks based question was there. So what was the question? He given 5 processes are there. There are 5 processes. Okay. Use a shared resources. Shared resources of k instances given now. K copies something given. Okay. K copies of R type resource. R type resource. So each process demands 2 copies of K. 2 copies of R, you understand now. 2 copies. It is asking for 2 copies now. What is the question? What is the minimum value of K such that So deadlock free operation. Asking for deadlock free only, right? Very standardized thing, correct or not? How to solve this one? 5 process P1, P2, P3, P4, P5 is there now. Their maximum demand is what? 2 copies, 2 copies, 2 copies, 2 copies now. One line also given in the question now. Each process demanding the 2 copies of K, 2 copies of R here. Now, like second resource is can be acquired to a process after acquiral of the first resource. The line is given now. So second copy can be taken after acquiring the first copy now. Allocation is what? So I can do it, no? I can give 1, 1, 1, 1, 1, 1, 1, right? This lead to deadlock here now. So I have a side, suppose 1, 1 copy if I given it. Now then next second copy I can give it. Suppose everyone holding and waiting for one more copy. If I give one extra here now, this will solve the problem of deadlock now. Total how many? 5 plus 1, 6 copies. If minimum K value, K equal to if I have a 6 copies now, 6 copies of R only. The R only they should ask, but use of K here now. If I have 6 copies, definitely there is no deadlock in the system. So answer for this question is what? 6 numerical answer type of question this is. So numerical type answer question. Yeah, some more questions from mathematics our faculty is going to discuss.
Thank you, Ravi sir. So my dear students, 10 minutes. So see students, 1 minute, Ravi sir pen. So here, see the questions have gone through the mathematics. There were somewhat tricky questions, my dear students. So actually there is one question related to the matrices. But if you go through the options, no, it would be tough. It would be very easy. But if you go through the concept, it will be time taking. As far as I have seen the questions until now, 6 to 7, there are 3 questions which are straightforward and 2 questions are bit tricky. So let us discuss some of the questions which we have come across now. So my dear students, as part of this, there was a beautiful question. The question here is f of x. Just a second. Just a second, students. Here the question is very simple. There was a question given from the differential equations. F of x calculus. So f of x is equal to c1x, c1 e power x, okay, minus c2 log e into 1 by x, okay, for the condition x greater than 0. Now, my dear students, for other values, for any other values, it is given as 3. Now, the function is continuous. Now, the function is continuous. Given as the function is continuous at x is equal to 0. Okay. They are asking what is the values of C1 plus C2. Now, see, this is a simple side. If for a function to be differentiable or for a function to be continuous, left hand side, left hand limit should be equal to the right hand limit. So similarly, if I talk about the left hand limit here, limit x tends to 0 plus, okay, here we have the equation c1 e power x minus c2 log e power 1 by x. Right, my dear students? So here if I substitute here x0, e power 0 is 1. So c1 minus c2, 1 by 0 is something like infinity. So by default, what should be the value of c2 here? Because it is multiplied with a c1. So here c1, here c. This value will be equal to what, sir? C2 should be equal to by default be 0. Now see, here from the left hand side we got 0 plus s c1. So right hand side what we can get? Right hand limit what we can get? We can get a value of 3. So c1 is equal to 3 and c2 is equal to 0. Now my dear students, he is asking what is the summation of c1 plus c2. So remember what I have observed in the c1 plus c2 is nothing but 3 plus 0. It is nothing but 3. Sir, let me tell you one important logic here. Yesterday in the instrumentation paper also, We haven't seen a similar question, but in calculus, especially in limit, for a function they are trying to give, and by the rule of continuity and from the rule of differentiability, they are asking a question both in instrumentation and also in today's CS paper. So what is the summation of C1 plus C2? The summation of C1 plus C2 is nothing but the value as 3. I hope you are clear, my dear students. Now, my dear students, there was another question in the calculus part. See here, the question is, similarly, there was a question, f of x is equal to what, sir? What is the formula? F of x is equal to mod x by 2 minus x into x minus mod x by 2. X minus mod x by 2. So here they are asking what is, they have given the option, it is an MSQ question. There is a local maxima, local minima, and the other one is f dash is continuous at x is equal to 0. Similarly, f dash is differentiable. Okay. Now, whenever this kind of question is given, you have to take two cases, my dear students. Suppose if x is greater than 0 here. When x is greater than 0, mod x will be positive. Am I correct or wrong? So it will be taken as x by 2 minus x into x minus x by 2. So this value will be equal to how much, sir? Minus x by 2 into x by 2. So this value will be minus x square by 4. This is the condition for x greater than 0. Okay. Now similarly, if x is less than 0, what will be the limit, sir? What will be the condition here? Mod x will become minus x. So here it will become minus x by 2 minus x and x minus of minus x by 2. So if I see here, this will be equal to minus 3x by 2 and here it is 3x by 2. So it will be equal to how much, sir? Minus 9x square by 4. So what is the value here? So we can come up with this, sir. So here you can write, when x is greater than 0, we are coming with a function, what, sir? We are coming up, when x is greater than 0, it is minus x square by 4. Okay, when x is greater than 0. Similarly, when x is less than 0, it is minus 9x square by 4. So these are the two values you have to remember here. Now, anyhow, when I substitute x 0, in both the cases it is 0. So f is continuous. F is continuous, you can say. Okay, now we have to find out whether f dash is continuous or not. So if I see here, f dash of x is how much, sir? This will be 2x by 4, that is minus x by 2, right? And what is f dash of, if this is the case for x greater than 0. The other case will be what, sir? F dash of x is how much? Minus 18 by 4. Minus 18 by 4 is minus 9 by 2. Yes or no? Yes or no? This is x dash of 0. So here, minus 9 by 2, 2 x. So here, my dear students, now we have to find out the double derivative also. F double dash of x is minus 1 by 2 and f double dash of x here is what, sir? This is equal to how much? This is equal to how much? Minus 9 by 2. But both the values are not equal. So you can say that f dash is not differentiable. Actually, they have given the answer as f dash of not differentiable. So this is also correct. And definitely, see, when f dash of, see, when you say here if you see in both the cases, 1 second, sir. If you see here, in the f dash of x, it is a negative value. So negative value indicates it's a local maxima. So the options here are local maxima at x is 0, f dash of x is continuous at x 0, and f dash is not differentiable. So these are the three options which are right. Okay. Next, my dear students, there was another question given. This is a kind of random question. So here they have given the values x, 1, 2, 3, 4, 5, 6, 7, 8. And they have given the expected values. They have given the probabilities of this. Sorry, they have asked 1 by 6, 1 by 6, 1 by 6, and 1 by 6. Remaining cases it is given as 1 by 12, 1 by 12, and 1 by 12. Now, my dear students, what he has asked here, he is asking what is the expected value. He is asking what, sir? What is the expected value? So, expected value is something like multiply both of them, you will get the answer. Okay, so if I take 1 by 6 common, 1 by 6 is for 1, 2, 5, and 7. So, I can take 1 by 6 into 1 plus 2 plus 5 plus 7 plus 1 by 12 into, what are the remaining values we have? 3, 3 plus 4 plus 6 plus 8. Okay. So if I see here, 1 plus 2, 3, 5, 8, 15. So it is 15 by 6, 3, 7, 13, 21. 21 by 12. So here it is 2 LCM, 30, 30, 51 by 12. 51 by 12 is nothing but equal to 4.25. So what is the answer here, sir? The answer is 4.25. So I hope you are clear or not. See, students, as far as mathematics paper is concerned, if you know the concepts, it is easy. But some questions are bit lengthy, sir. That is for sure. Okay. Just a second. I have another question. Yeah. There was a question here. The question here is an unbiased 6-phase dice. A unbiased 6-phase dice. A unbiased 6-phase dice whose faces are marked with whose faces are marked with 1, 2, 3, 4, 5, 6. Okay. The probability of number of appearing in the probability of number of appearing in the second roll are marked 1 and is rolled twice, sir. Here it is rolled twice. This is rolled twice. Okay, here is what he is asking is the probability of number of appearing in the second roll is an integer multiple of number of appearing on the first roll. So they have a see it should be a multiple, sir. Every multiple is what are the different multiples we have? It can be 1, 2, 3, 4, 5, 6, right? And what are the multiples of 2? It can be 2, 4, 6. What are the multiples of 3? It can be what, sir? 3, 6, and next 4, 5, and 6. Now combine all these combinations. We have 6 combinations, 3 combinations, 2 combination, plus 1 combination, 1 and 1. If you combine all these 6, 3, 9, 11, 14. But what will be the probability of 2 dice rolled? It will be 36 times. So the probability will be taken as 14 upon 36. This value will be taken as 7 upon 18. I hope you are clear. Okay, sir. There was another question also in matrices. Okay. The question here is for n greater than 1. What, sir? For n greater than 1, the maximum multiplicity of if for n greater than 1, the maximum multiplicity of any eigenvalue of n by n matrices with real entries is Sir, this question is somewhat tricky if we go with the concept. I'll go with the option method for now. They have given 1023, B 1025, C 512, and they have given D option. I'm not sure, sir. One second, let me check. They have given some option like 255, I think. Yes. So here, if there is a 4 by 4 matrix, sir, and one more second, it is a 4 by 4 matrix, I think. Just let me tell. This question is different, I think, sir. Okay. Okay, I think I'm not sure about this question, so I'll be ending up to here, sir. So I have forgot the question actually. So you can take up to the previous question. I'll get back to the question next time. Okay, after the next session. Means Ravi sir will be handling the remaining questions. Okay.
One of the question from COA. MCQ question, and from catch address mapping methods. Address mapping methods from topic is what? Catch address mappings. What is given? He said consider main memory. That means physical address space used it. 2 power of 32 bytes given now. And cache memory size 2 power of 23 bytes given. Block size given. Block size is 128 bytes given now. So mapping method used. Mapping method is, he said direct or k-way set association. K-way set associate. Okay. Where he use the word where k equal to 2 power of L and comma L belongs to 1 comma 2 comma 3, like this given now, where k equal to 2 power of L, L is 1 at the 2-way, 4-way, 8-way set association we see now. So now tag bits. So tag bits in direct mapped. Direct mapped is use the word M, and so tag bits in set associative is n bits. So with this respect, no, which of the following? So which of the following option is correct? Okay. Option A is given like the relation is given, no, n equal to m minus L. Option B, n equal to m plus k. Option C, n equal to m plus L. Option D, m equal to n plus something else, some relation, some kind of a relation only given. You might have notice. Check it this one now. Now simply the relation between tag bits in direct mapped and set associative relation only they are asking now. So one thing we know here, suppose one thing I'll tell you directly with observation we can able to answer it. Suppose direct mapped, okay, direct mapped is there. When direct mapped or when you compare with some k-way set association assumption. Okay, in a k-way, suppose here a tag bits, I am talking on tag bits. If you are getting tag bits, let's take example, I'm talking about something, let's take m only here now. I'm taking m. So how many tag bits will be in this this one? So this will be, as it is, you understand now, when it is converted into here, it will increase m plus log k base 2. Log k base 2. M plus log k base 2. So this is only tag bits will change. With this one, we can able to directly answer. Now here is the word where in this question is, no, k is given 2 power of L value. 2 power of L value. Now what will come now? 2 power L, if you substitute, you will get tag value will m plus L only now. So this is a k-way set of solution. Tag bits is represented n. So n equal to m plus L will get answer. Direct answer only, right? Direct answer only now. So what is the direct answer? So option C is the right answer for this question. But let's understand, let's do it with this. So what will matches here now? So direct map of tag bits, how to take physical address. How much physical address? 32 bits. So 32 bit is divided into tag, block offset and word offset. Since block size given 128 bytes, nothing but 7 bits required. So here number of blocks, n value I can calculate, total cache size 2 power of 32 by, 2 power of 23 by 2 power of 7, isn't it? So this value is 2 power of 16. So now for this 16 bits required. Then the tag bits. So tag bits equal to how much now? 16, this is 23 means 7 plus 2, 9 bits. 9 bits only. So just 23 means what? 7 plus 2, 9 bits will get here. Correct. So once again cross check the data. Block size 128 bytes, cache memory 2 power of 23, 2 power of 23 only given. So 2 power 23 by 2 power 7, 2 power of 7, 3 cancel, 4 cancel, 16, correct. This, now this is nothing but he said m. So now when it is comes to k-way set association, k-way set, k equal it can be 2 or 4 or 8 based on the values which is given now. Now physical address is divided into what? Tag bits plus what? Set offset and word offset here. Word offset will not change. Number of sets will change. Number of sets based on this one. Suppose 2 if you given 2 power of 16 by 2 I can take it. 2 power of 15. 2 power 15 nothing but 15 bits required for this. Now tag bits will be what? It will be 10. 10 bits will happen now. One relation I can observe now. This value is what? N, right? This value is N now. So with this one, can I compare some relation now? So what is given? N equal to this N value nothing but M plus L is there. One option is given now. So what is this L, sir? This L is what? This L only, right? So I have taken like, no, is given now. L belongs to this, right? L belongs to 1 comma. If I take L is 1, 2 power of 1 is what? 2. Two-way set association, right? So 2-way set association L value. So L value is what? 1. M value is what? M value is, this is 9. 9 plus 1, 10. This relation holds good now. So this data are not required to answer it. This data not required to answer. Getting my point? If I take it this 4-way set association, so this will be 14, right? This will be 14. Now it will come 9. So now, so what you can say it, so this is 9 plus, so this become 11. So 9 plus this will be 2 will come, right? That is how we can answer it. I hope this is clear now. So simple thing to understand, whenever direct map you are expressing it to 2-way set association, this tags plus log of that set I have to take it. So this log of k-way set association, but it mentioned here that is L. So with this one only we can able to answer. Options is the right answer for this question. I hope this is clear, everyone. So comment it, all of you marked same answer, M plus L. Another question. From COA, very regular question from floating point, very expected area you can say. Floating point, especially IEEE 754 standard format is given. Single precision only given. Single precision based question now. Is given x value. X value is given as 34C 5 zeros. XY value is given 35A 5 zeros given now. Then Z equal to X plus Y is dash in IEEE format. In IEEE format only. IEEE 754 single precision format only given now. Some options are given now. A, B, C like this. Those are in IEEE format only. They are there. Anybody got the answer? So first of all, I should know this X value, right? X value. You can take a decimal, you can substitute, but not required to take to full decimal. Some format, at least you can write value expression now. Then, so X has given 34C 5 zeros, right? When I write in binary 00011 0100, right? 34 only, right? 34 only, right? So if numbers you check it, these numbers are correct or means so just values only will change it. Okay, 0100 1100. So rest are zeros only now. So this is sign bit 33678. Till this point, this is what exponent. This is mantissa. We know the value expression -1 whole power of s 1.m base 2 into 2 power of e minus bias is 127. So S value is 0, positive only. So now simply 1.m value is what? Here is 1. Base 2 into 2 power E value is how much now if you evaluate? 1, 2, 4, 8, 16, 32, 64. 32, 64, right. So this is 96 plus 8, 1, check, sorry. Which 3, 3, 6, 7, 8 only, right? 1, 2, 4, 1, 2, 3, 4, 5, 6, 7, 8 bit number only, correct. 1, 2, 4, 8, 16, 32, 64. So 96, correct? The value is correct only, right? So 104, 105 only, right? So 105 minus, so 127. So 1.1 into 2 power of this value is how much? Minus 22 will come, right? Minus 22. This x value. Similarly, we'll take for y. So keep it as is this one now. Y value is 35 C 00000 now. So 0011 101 0101 1100. So 000 rest values. This is sign bit 33678 till this one is the exponent. This is a mantissa, isn't it? This is a mantissa. Sorry. This is not C, this is A. Sorry. This is A. So A means here is what? 10100000 like this will be there now. 33678 till this point is the exponent will come now. This is a mantissa now. So now value expression again I'm writing. Anyway positive number. So I'm writing 1.010, right? Base 2 into 2 power of E. What is this E value? 1, 2, 4, 8, 16, 32, 64. Right. So 96. So 96, 104, 107. Am I right or not? 107 minus 127. So this is nothing but 1.010 into 2 power of 20 minus 20. This is what y value, this is what x. So now z equal to x plus y. What is x value? 1.1 into 2 power of minus 22 plus 1.01 into 2 power of minus 20 is there now. Let me shift this part here. have to make it equal, right? We can do it. 1.1 into 2 power of minus 22 plus 101 point, right? 0 if I take like this. So right shift I'm doing. So minus 22 comes. This simply what you can say, we have to add the 6.1, am I right? So 6.5, so into 2 power of minus 22. This we have to represent, right? This you have to represent it. So now 6.5 into 2 power of minus 22, you have to represent it. Is it? So right shifted, no? Right shifted. 2 times I right shifted, 5.0 will come. When I evaluate in this number in binary, right? When I write decimal, 5 plus 1, 6, 6.1 is nothing but 0.5, correct? So when I'm writing 110.1 only, right? Base 2 into 2 power of minus 22 now. So we have to normalize this. I have to shift it. 1.101 into left shifted, right? 2 times. So minus 20 will come, right? This one. Minus 20 came now. So 1.m form is there now. Capital E is nothing but minus 20 plus 127 is a bias. So this value 107 you have to load it. Right? This is my what you can say mantissa, right? The storage value, what value you have to store it here in the register, if you see, number is positive 0, exponent is 107. So 107 somewhere we got here only, right? This is only 107. 0 11 1 0 1 0 1 1, right? So directly write 0 11 0 11 0 1 0 1 0 0 1 0 11, sorry, 0 11. So this is a E we got. Okay. So what is the mantissa here? 101. So rest of the zeros will be there like this, many zeros. So I can take it, this is one number, this 4 numbers, this is number. So 4 digits like this will go, right? So 0 triple 1 3, this is 5 3 5 double 1 0 1 C D D. Now rest 5 zeros I have to keep it now. If the values are correct, your answer, one of the options should be this. If the given values are correct, one of the option should be this one. So that values need to check what values are given, this one. Based on the values only will change. But that very straightforward question also we can say this one. Very straightforward question. Yes. So especially from functional dependencies. The given relation of PQRS. So they say FD is X determines Y. So this given X determines FD. With this relation, this given option A, if P comma Q determines R, then P determines R or Q determines R is given. Option B, P determines R, Q determines S, then P comma Q, this PQ determines R comma S. Option C, P determines R, then PQ can determine, PQ determine can R. Option D, PQ determines R and P determines R, then Q determines R is there. P comma Q. P comma Q determines R, P determines R, then Q determines R is given now. Look at this option A. P comma Q determining R, together determining R. So this implies what? P determines R or Q determines R is saying now. Actually, both together determining R. We don't know whether this will, one of them will determine or not. We cannot take this one. P determines R if P determines R, Q determines S is there. We can tell both this combination can determine RS. If P determines R, then PQ determines R. P alone can determine R. Having some more extra attribute definitely can determine R also. This is right. I hope you understand now. P alone can determine R. Adding something to some attribute to what P, it definitely can determine R. So PQ both together determine R. So now P determining R is there now. But can you compulsory say that Q determining R? That we don't know. PQ together can determine one FD, other FDs P alone can do it R. But we don't know Q will do it or not. This is impossible. So therefore now option B and C are right. Option B. So this MSQ question. I mean this year there are many MSQ questions were there. Many MSQ questions were there. So one question from operating system. OS. OS, if you talk about operating system, fork based question is there. One. CPU scheduling algorithm, one question is there. And there is one more memory based question is there. Now disk schedule, disk structure. So disk structure based questions seen it now. We solve the fork based. Let's see the CPU scheduling algorithm based question. So CPU scheduling algorithm, this given first come first serve. First come first serve based question is given now. They said two type process are there. Two types processes. So they're named as A actuator. C is there now. A and C is there now. Okay. A and C. There are two types of are there. A takes 6 seconds CPU bus time. This is a CPU bus time. You understand now? I'm writing now. So A, CPU bus time. Bus time simply I'll write. Bus time A will take 6. So C will take 8 seconds. 8 seconds given now. Getting my point now. Now this process A arrives. A arrives at time T equal to 10. So now initial arrives. After that A has types A comes at 10, 20, 30, 40, 50 like this. So 1, 2, 3, 4, 5. The C comes at intervals 11, 22, 33, 44 and 55. Now question is asking what is the average waiting time? Waiting time of the process, time of 10 processes is dash. So up to 1 decimal point he asks question now. Average waiting time of 10 process. There are 10 means A is coming this many instances, I understand. C is coming this many instances. So if I write it, what is happened now? A first time comes at arrival time for take, arrival time and bus time for take. Process ID, if I write it like this, A1 comes at 10, is bus time 6. So A2 will come at what? 20, bus time 6 only like this. So A3 comes at 30, bus time is what? So better I'll write like this, A1, C1 will come at 11, 8. So A2 come at 20, 6. C2 come at what? 22. It takes 8 unit of time. So A3 comes at 30. It takes 6 unit of time. Correct. So like this, all values are there now. Let's draw the Gantt chart here. Let's draw the Gantt chart. This one now. Okay. Because ready queue, if you see it, so ready queue, if it is see it, first A1 came, then C1 came, A2 came, C2 came like this. A3 came, C3 came. So A4 came, C4 came. A5 came and C5 came. Like this, a ready queue contains like this. Okay, this is a ready queue now. So this order only we have to execute them. Let's draw the Gantt chart. So generally CPU time start with what? 0 only, right? So ready queue. Ready queue is what? Arrival. Who is arrival first? A1. A1 came at So at time T10 only they said, time T10 only. We'll start with the T10 now. A nothing but there are two types of process, the instances. So total 10 process available, like, getting my point. 10 processes are there now. 10, 20 like this. So I give a number A1, A2 only like this. Getting all of it. Now look this. So A1, C1, A2, C2, A3, C3, A4, C4, A5, C5. Correct or not? So you know, right? A1 first, 10 came. If I schedule first come first serve on A1, this will take 6 unit of time, means 16. So that I can schedule what? C1. C1 takes what? 8 unit of time. Sorry, 8 means what? This value 24. Then I can schedule what? A2. Because 10 it came. It 11. It came at what? 20. It came at 22. It came at 30. It came 33. It came 40. It came 44. It came 50. It came 55 like this. So I schedule C1 completed. Then I can schedule what? A2. A2 takes what? 6. This will be 30 get completed. I can schedule C2. C2 will take 8 unit of time, 38. Fixed. A type will take over 6, C type will take 8. Schedule A3. As per this data only I am trying. If the data changes, now answer will change, ma. Please understand. A3. So 38 plus 6, 44. I can schedule C3. So 44 plus 8, 52, right? I can schedule A4. So 58, right? You can schedule C4. This will be what? 66. Sorry. C will take 8, right? 8 unit only, na? 66, correct. C4. So A5. So A5 66 plus 6, 72, right? Then I can schedule this one. C6. C5. So this value will be 80. If I'm not wrong, check it all of you. So we have to find out the average waiting time, correct or not? Average waiting time now. So average waiting time of the processes. So process A1, I'm talking A1. A1, the values are written, arrival time written. You can check it when you, the time at which we scheduled it. One formula is that, so average waiting time nothing but turnaround time minus what? Bus time, I can remove it, right? How to get a turnaround time? Completion time minus arrival time, I can get it. Completion time minus arrival time now. Or else directly I can see from the Gantt chart. A1 came at 1, we scheduled at what? 10. So it came 1, scheduled at 10. So 0 waiting time. C1 11 came, C1 we scheduled at 16. Waiting time is 5. So talking about A2. A2 came at 20, we scheduled at 24. 4 is a waiting time. I'll write here. So 0 plus 5 plus 4. 4 is what? A1, C1, A2. C2 I'll talk. C2 came at 22. C2 we scheduled at 30. So 8 is a waiting time. I'll talk about, this is for A1, right? This is C1. We'll get confused. That's the reason I'm writing C2. A3. A3 came at 30. A3 scheduled 38. So 8 is a waiting time. Now this is what A3. We'll talk about C3. C3 came at 33. C3 came at 33. We scheduled C3 is 44. How many minutes waiting? Seconds, 11 seconds now. So this is for C3. C4, A4. So A4 came at 40. A4 schedule 52. 12 waiting time. 44. Sorry, sir, not 12. A4 came at 40. A4. Where is A4? A4 came at 40. We schedule 52. Correct. 12. Plus C4 came at 44. We schedule C4 is what? 58. 6 plus 8, 14. Similarly, A5. A5 came at 50, 66. So 50 rate 16. So this came 55 is scheduled 72. So 17, 19. 19 seconds, isn't it? 55. 15 plus 2. Sorry, 17. Not 9. 17, right? So divided by total number of process, how many? 10. So just take this value. Some of you tell me the answer. 5 plus 4 plus 8 plus 8 plus 11 plus 12 plus 14 plus 16 plus 17 divided by 10, right? 9.5. As per this data, average waiting times comes 9.5. Is it correct? Those who solve this question, answer is right. Is it 9.5 seconds? Average waiting time? Anybody solved? Any one of you solve this question? I think there is one question from operating system, especially for memory management based question. Is given TLB is given. TLB is there. Page table also there. Page table is there, and cache memory also there. Cache memory is there. Cache memory, and of course main memory also will be there now. These are the main component. So now if page is removed from, page is evicted, like no, evicted from main memory, then it will be invalidated in the cache. Invalidated in the cache is given now. With this respect, so which of the following never, so never happens? Which of the following never happens? So like this is given statement. Option A, TLB miss. TLB miss. TLB miss, page table hit and catch it. Option B given, TLB miss, page table miss, catch miss. Option C given, TLB miss, page table miss, catch it. Option D is given, TLB it, TLB it, page table miss, page table miss, catch it. Like this statement given. Any one of you answer this question? So what we know is that concepts from memory management, if you studied, so there is a TLB like this. Short form I'm writing now. TLB contains, recently referred pages corresponding to frame number will be there now. So now here is a page table, right? Page table has here page numbers will be there. Inside frame numbers will be there, right? You can take this frame number, we can pad D. Okay, here is a cache memory now. This is a physical address cache memory is given now. So I can search it here like this one way. So this is a physical address. So through this also I can get the physical address. How? Frame number. So I'll generate CPU, right? CPU generates the logical address. So logical address has frame number offset. P I'm searching here now. P I can search here also. So D will be connected here like this. D will be connected. So this D also can be connected here now. So we can generate this physical address. So now this is will come P, right? P plus F, I can generate the physical address like this, the structure. Now here is a main memory, right? This is a main memory now. It's a main memory. Frames will be there now. Option TLB miss occur. So TLB miss means no entry is there. Comma page table it is there. Page table entry. Page table as it. This it is there now. Now cache it is saying now. Yes, example you understand now. All the page table entries cannot be stored in TLB because TLB size is smaller in compared to page table entry sizes. TLB size is what recently frequently referred page numbers only present, not all. So now every reference generated by CPU is not compulsory to be it here. It can be miss. If it is miss, we cannot say always it here. It can be it or miss also can happen. That depends on the virtual memory concept. If it is it, yes, there is a chance of it in cache also because physical address when I get it, I can go and search into cache memory here. Here is a content will be there, right? Therefore, what I can say, this can be true. This true I am writing now. Now TLB miss occur, page table miss occur, cache miss also is saying now. Suppose I am trying to search it here. It is entry is not there. That the page number not present. Same page number trying into searching what page table. So that is also miss. That is also miss means what? What does mean? The page has not brought from secondary memory to main memory. That we call page fault. This is what page fault. So it is not there in main memory now. If it is not there in main memory, definitely not there in cache memory. This you remember. So there is no chance, there is no case that something is present cache memory which is not present in main memory now. Cache memory is inclusive memory. Whatever cache memory has definitely will present in what main memory. Therefore, so TLB miss, page table miss, cache miss can happen. This is true. TLB miss occur, page table miss occur is saying cache it is saying now. So when this is true, this definitely false. As I told, right? If the page is not in main memory, definitely is not in cache memory. He also use word. If page is evicted from main memory, then it will not, it is what? It will be invalidated in the cache. Cache is, entry is invalidated. This is how, it cannot be hit. Never be hit this one now. TLB it occur. Page table miss occur. Cache it is saying now. TLB may entry it is there. But page table entry is not there. Page table mein entry is not there means it is the page is not present in main memory. If the page is not present in the main memory, cache it never happens. So this is also false statement. So never happens are what? What is the never happens? C and D. So is the MSQ question? MSQ question. C and D are right answer for this question. I hope this is clear, everyone. So we'll search some more questions. We'll come up with this one. So now in this session, like most of the memory-based questions we discussed. So later part, the complete paper, once response sheet comes out, for every individual question, every question we'll give the detailed solution. We'll discuss another session also. Now try to tune to the channel. So second session. So afternoon session, detailed solution, this paper analysis. So that the session will be at evening, that's 6:30. So we'll assemble it 6:30. Thank you all. Thank you so much, everyone.